Hello everyone again and welcome to my channel. Excited to be back again and thank you for actually stopping by to check out this video. And now we're going to focus on the third and the final part of our series, which is the applications of using charged particles in electricity/magnetism. We've talked about that of the velocity selector, and we also looked at the Thomson's model, which uses the idea of cathode ray experiment to actually determine the charge to mass ratio of an electron. And now here we're going to look at the mass spectrometer and its uses majorly in chemistry, where we actually detect various compounds and how we can actually break compounds as well in order to see all the fragments that are being made during the collision of particles in a particular system. Now in this mass spectrometer we have a particular schematics in here, or I would say a skeletal diagram of this particular mass spectrometer. We have this particular segment here and we have this other segment over here. Now let's dive really deep into the applications of this. And now first of all, we need to take note that this here releases positive charge ions that are actually tagged as well. So if you have a specific neutral molecule, you can actually subject it to it being a positively charged particle, and then once you put it in this particular case, this particular gun shoots it out, and this huge beam can actually be narrowed down into smaller beam of positively charged particles with the help of slit 1 and slit 2. By that way, our ion, which is our positively charged ion, will make it into this particular chamber, which has a channel containing electrical fields and magnetic fields in here. So this positive charge with its velocity will make it in, and then our electrical field is generated by the positive charge on this rod and that of the negative charge on the other rod. So what happens there is that we do have an electrical field that is actually going to the right. Now this electrical field is perpendicular to that of the magnetic field, and the magnetic field in this case is actually pointing towards me, which is actually shown by these dotted lines over here. So once you're able to combine both fields in here, we can be able to actually do this in our way to block all ions except those that are actually speed is equal to that of the ratio of E over B. Now this is actually the velocity that was determined using our velocity chamber, or which is the velocity selector, and the velocity selector says that at constant speed and when there is no deflection in there, we should expect our electricity or electrical field to be in that ratio with respect to the magnetic field in there. So once we're able to determine the ratio, then we can be able to actually calibrate this particular system in such a way that we can allow a specific positively charged ion to make it through this particular region all the way to our third slit. Now what happens next is that once it makes it to the third slit, what happens next is that this ion, which is a positively charged ion, will make it out and form a semicircle or an arc into our detector over here. So this is our particle detector, and the radius of this particular arc here is actually equal to the mass of that particle multiplied by its velocity over the quantity of its charge multiplied by the magnetic field that it is subjected to. Now take note that if you want to be able to understand more about separating various molecules in terms of them having the same positively charge, we separate them based on the mass of that particular molecule and its relationship with the radius that it's been making once it makes it out of the third slit over to the particle detector. Now let's say for example we have one particle making it out into this particular detector. We call this molecule here positively charged, and it's what, M2. Now we have another one. Now mix it out into the detector with a positive charge on it. We name this M1. What we realize is that when ions with different masses strike the detector at different points, the particles with greater mass, which is in this case M1, will travel its path with a larger radius, which is R2. This will be greater than our M1 radius, which is R1. So in this case, what we see here is that we have our radius here for R1 with respect to M1, and our radius here R2, the bigger one, which is with respect to the mass 2. So that's about it for this particular video, and how you're able to actually separate molecules of the same charge using mass spectrometer, and also using that to actually determine the compound that is in focus in here. Also looking at how we can actually selectively choose the specific ion that we want by using this particular velocity selector chamber region in this mass spectrometer, with the help of manipulating the electrical field versus that of the magnetic field to see which ratio correlates by calibration of this to get the specific ion that will make it pass this into our detector. All the same, thanks for following me through this trade. I appreciate it. Hit the comment down below, let me hear your thoughts. Hit like, share, and subscribe, and be smart. Bye.